Welcome back, Syracuse Math Kitties. In today's video, we're going to tackle lesson number 4 in our math packet, module 4, which deals with exponent properties. We are going to be looking at rule number 3, okay? And we have a little sample problem here. And before we continue and move on to solving any of your problems here, we're going to study our sample problem so that we can have a good understanding of what we're being asked. So go ahead and let's read this. It says, when dividing powers of 10, the exponent in the denominator is subtracted from the exponent in the numerator. This makes sense because, okay, and then let's look at this right here. Okay, this makes sense because 10 to the 9th divided by 10 to the 3rd, all right, this is just our sample problem, is equal to 10 to the 3rd power times 10 to the 6th power divided by 10 to the 3rd power. Okay, then we can, as you guys can see, the 10 to the 3rd power and 10 to the 3rd power divided by 10 to the 3rd power, those two cancel and they become 1, right? And then all we have left here is 10 to the 6th power, right? So the answer is 10 to the 6th power. Now you can go through, kind of showing your work this way, or you can also actually show work just by using this, this rule here. So in other words, 10 to the 9th power divided by 10 to the 3rd power is equal to 10 to the 9th minus 3rd is equal to 10 to the 6th, because 9 minus 3 is 6. Okay, now before we move on, let me kind of show you how this rule number 3, kind of incorporates rule number 1 that we learned earlier. So let's refer back to our rule number 1. Okay, hold on, this is not cooperating with me. Hold up. All right, so rule number 1 says, when you're multiplying 2 powers of 10, you're going to just add the exponents, right? So here, let me show you what I mean by that. Okay, how do we know that 10 to the 9th, okay, how do we know that 10 to the 9th is going to be equal to 10 to the 3rd times 10 to the 6th? Well, that's because of our rule number 1, right? Our rule number 1 says, okay, rule number 1 says when we have a power of 10 multiplied by another power of 10, we are going to add the exponents. Okay, and so 3 plus 6 adds up to 9. Now a whole lot of other numbers will add up to 9. All right, 1 and 8 adds up to 9. 2 and 7 adds up to 9. But the reason we chose, the sample problem chose 3 and 6 is because on the bottom here we have 10 to the 3rd, right? So if we break down the top part into 10 to the 3rd and 10 to the 6th, then as you guys see, we get to cancel part of it. It makes our life a lot easier. But anyways, when you're solving these problems down here, you're definitely not required to show all of this work here. This is just for you to really understand what's going on in the background. Why does it make sense? Why does this keep popping back? Hold on, you guys. Okay, so it just, this sample problem is just showing you why rule number 3 totally makes sense. All right, but for sake of doing your work, this is all you have to remember. Okay, and then of course with each of these additional lessons, we are always remembering previous rules, right? Because definitely rule number 1 came in handy here. All right, so number 1, you're going to have one freebie, because this is something that we did not learn before, and it's something that actually you just need to remember it, okay? There's like a long proof or explanation as to why anything to the 0th power is equal to 1. All right, so for now, I'm not going to go into detail why that is. All you have to know is that any number that you raise to a power of 0 is going to be equal to 1, right? So then you're just going to apply this rule up here to any of these to solve them. Okay, so for example, this one right here, we have 10 to the 3 minus 3, right? Because we are subtracting the exponents, right? When we are dividing two powers of 10. And so because we know 3 minus 3 is 0, then this is 10 to the 0th power, which is 1. Okay, which in a way, this proves or shows you why something to a 0th power is equal to 1. Okay, so you kind of get that explanation there. Then with this one right here, you're just gonna calculate each one individually and then add them up. Okay, then for number 2, just make sure that you do each part one by one, and don't skip steps. Don't forget previous rules. So let me see, I'm gonna do 1 here. I wonder which one you guys would find the most complicated. So let me see. I don't know. I guess let's just do this one right here. I'll just do the first one. So we have 10 to the 3rd power times 10 to the 4th power. Now remember, rule number 1, okay, when we are multiplying two powers of 10, we're going to add the exponents. So we're going to have 10 to the 3rd plus 4 divided by 10 to the 5th power. There's nothing happening on the bottom. We're just going to carry it over. Okay, and that's equal to 10 to the 7th power divided by 10 to the 5th power. Okay, so up here we actually used rule number 1. Okay, we solved for that, and now we have 10 to the 7th divided by 10 to the 5th power. Okay, and now we're going to apply rule number 3. Okay, and so we have 10 to 7 minus 5, and that is equal to 10 to the 2nd power. All right, and then we know that if we want to really take it all the way to the end, we know that the 2 or the exponent tells us that we're going to multiply 10 with itself twice, and we know that that's 100. All right, so there you have it. Take a stab at these guys right here. If you're struggling with them, of course, as usual, look at the sample problem. Try to copy what's being done there. If you still don't understand it after looking at the sample problem again, I would most definitely reach out to Miss Piraino or to myself, Miss G. We will be more than happy to help you. And then number 3 is a challenge question. All right, let's read that. The sun is roughly 10 to the 2nd power times as wide as Earth, right? The star KW is roughly 10 to the 5th power times as wide as Earth. About how many times as wide as the sun is KW? All right, explain how you know. Okay, so we are comparing sun and KW, right? So sun is 10 times, so sun is 10 to the 2nd as wide as Earth, and this KW star is 10 to the 5th power times as wide as Earth. How many times as wide as the sun is the KW? All right, so think about it. You're going to use some of these rules from previous lessons, and let me know how you do. I'm here to help you. So until next time, please stay safe. You're loved and you cared about, and we are wishing you the best over this weekend and beyond. Take care. Bye.